Okay, last thing we need to cover in chapter 5 is a system of linear inequalities. So with these, you need to be able to show visually the solutions, okay? Because we're going to have more than one solution. So make sure you pay attention to this. Make sure you practice. There will be a big idea assignment on linear inequalities. So make sure you ask for help if you need help. So what you're going to do here is we're going to be graphing two lines, and then we're either going to have a solid line or a dashed line, very similar to when we graph inequalities on a number line. So if you remember, when it was just greater than or less than, you used an open circle. So as soon as you said it was equal to, we closed in that circle. Well, now when we see equal to, we're going to have a solid line. If we don't see it, like in this first one, I see just greater than. When I sketch this line, it's going to be a dashed line because the points on this line are not actual solutions. So we want our y values to be greater than 1/2 x minus 1. So this is in slope-intercept form. We put a dot at -1, and the slope is up 1 over 2. Okay, so I'm going to do that a couple times just so I can draw somewhat of a straight line. I'm even going to go down 1 and to the left, down 1 and to the left. But when I connect these dots, it's going to have to be dashed or dotted. Okay, so what happens is we divide into two regions. We divide this graph into two sections. So since we want to be greater than, we are going to be dealing with all the points above. Now I'm not going to shade just yet. I'm just going to, just based on this first condition, only points that are above this dotted line will be solutions, okay? But we have another condition. So the other condition is, remember, a system satisfies all the conditions. So the second condition is saying that we will start at 2, and we're going to go up 2 and over 1. This is a positive slope, so this line's still going to go uphill at a rate of up 2 over 1. Now I can go down 2 and to the left, down 2 and to the left, down 2 and a left, but this time it's going to be solid because we can include all the points in this line because the inequality is less than or equal to. So as soon as if you see a little line underneath the inequality, you're going to have a solid line. Okay, and you should remember this from your Algebra 1 doing these. But now this condition says we're only going to deal with points that are below this, that are less than, which is that side. So now, putting both conditions together, I need to be above the dotted, below the solid. That's going to include all these points. Okay, remember, this goes on forever. So any ordered pair in this shaded region will make the top condition true and the bottom condition true. Okay, so I want you to try number 2 on your own. Okay, and then we'll go over it in class. This will be a solid line. This will be a dashed line. It's already in slope-intercept form. Okay? So now, what if it's not in slope-intercept form? That's why I want to take you through number 3. If it's not in slope-intercept form, we need to solve for y. I want you to solve for y, get it in slope-intercept form. So right now it's in standard form, and we do have to be careful with inequalities. If you remember back when we solved just regular inequalities, if you had to divide by a negative number, we reverse the sign. So that's what's going to happen when I solve for y for this top equation. Now it's going to be a solid one. It's going to be a solid line, but I have two moves that we have to do. So my first move is to subtract that 2x. Okay, it's a positive 2x on the left, but I'm going to bring it over to the right where the 1 is. Okay, but then I have one more move. I want a positive y. I want y and then mx plus b. So to make this a positive y, I'm going to divide everything by -1. But since I'm dividing by a -1, it's your job to remember to flip that sign, to reverse this sign of inequality. So now we're going to be above this line. So when we sketch this line, we're only going to be dealing with points above, greater than. So this becomes a positive 2x slope, and then my starting point is going to be a -1. Okay, so again, that's what you have to do if it's not already in slope-intercept form. So we know we have a dot at -1, and we know we're rising at a rate of up 2 over 1, up 2 over 1, up 2 over 1. I can go down 2 to the left, down 2 to the left. Okay, so plenty of dots to make a straight line. And since there's equal to, I make a solid line. Okay, and since we flipped it, originally it was going to be below the line, but since we had to solve for y, we're going to see now this is all the points above. And you can always test a point, like 0, 0 is above this line. You plugged in 0, 0 to the original, you get a true statement. Okay, that's what makes this a solution. Okay, now this other one's real easy to get by itself. Okay, so we have one move, it's a positive y, it's greater than, and then you just subtract that x. So now, just like that, it's in slope-intercept form, where I have a starting point of 2, okay, so the y-intercept is 2, and the slope is negative, which means -1, so I'm going down 1 over 1, down 1 over 1, and I can continue that pattern. I can go up 1 to the left, up 1 to the left. That's what a negative slope, -1 slope looks like. But now, make sure you realize you're looking for, or have to do a dotted or dashed line, okay? So, since it's greater than, we're going to be above this dotted, okay? So we need to be above both, actually. So above the solid, above the dotted, which means we have this region to shade, okay? So any point that's in this region, and you can name an order pair. So, for example, 1, and then 1, 2, 3, 4, 5. 1, 5 is a solution. So this dot right here that has an order pair of 1 up 5 is a solution because it makes both conditions true. Okay, and that's what a solution to a system is. Okay, so you try number 4. I'll just tell you this first one, that's a vertical line. So when you draw this one, it's just a vertical line that says all the x values are -3, but it's going to be a dotted vertical line. Okay, it has to be dotted, and you're going to be dealing with all the points that are greater, so to the right of that vertical line. And then try to solve for y. It'll take you 2 moves. Remember, you'll have to flip the sign because you're dividing by a negative, and see and sketch that, and try to do the shading. Okay, so we'll go over that in class, but I wanted to do just 2 examples of the odds, just so that you can get familiar with this process. And hopefully this is not the first time seeing linear inequalities. Okay, thanks for watching. Take care.